Hello, dear students. Greetings of the day. I, Mohammad Zishan, welcome you to the online classes of Blooming Birds Code School Sambal. Dear students, today we are going to study the geography of class ninth, and in that we are going to study the fourth chapter, which is the Earth's structure or interior of the Earth. Interior of the Earth. In this chapter, we will study how the interior of the Earth is, and we will study that how do we come to know about the interior of the earth. So dear students, for knowing the about the interior of the earth, what you can do, you can do digging. But how deep can you dig the earth? You can dig 100 meter, 200 meter, right? Or even 1 kilometer, but not more than that. Okay, means maximum depth of earth, the maximum has the earth has been dug to its maximum depth, and that is only 8 kilometer, not more than that. Okay, so we are not having such instruments or machines which can dig the earth. So how can we come to know about the interior of the earth? As we know that the earth is too deep, right? Its radius is 6378 kilometer. 6378 kilometer means if you want to reach at the center of the earth, then you will have to dig it by 6378 kilometer, then you will reach there. But we are unable to even dig for 8 kilometers, right? So how will we come to know about the earth? Will there be any ways, okay, sources of information, so that we can come to know about the interior of the earth, about the structure of the earth, right? So yes, there are so many things. Like the first thing is seismic waves or earthquake waves. Seismic wave or earthquake wave, this is sources of information. First topic, characteristics of IE second, third and fourth. These four topics we are going to study, right? So seismic waves, or you say these are the earthquake waves. Let me check the video. So these seismic waves tells us about the interior of the earth. What does these tells about the interior of the earth? These waves tells that up to the depth of 2900 kilometer, earth behaves as solid, right? Earth behaves as solid. And then it tells that from there till 5100 kilometer, right, it behaves as liquid. And then it tells that below that till 6378 kilometer, it behaves as again solid, right? So how do we come to know about this? We have not dug the earth, and we are telling that, okay, suppose if this is the earth, right, and this is the center of the earth, so from here till here 2900 kilometer it is acting as a solid, then 5100 acting as liquid, and then here 6378 again acting as a solid. How do we come to know? We have not dug. So these things, okay, are interpreted by seismic waves. We will study about the two types of waves in particular. I will not go in too much detail. So first wave is P wave, which is called primary wave or compressional waves, and second is S waves or secondary waves or transverse waves. Okay, secondary waves or transverse waves. These are the compressional waves, and these are the transverse waves. Okay. Now, how these waves, what are these waves? See, anything like, suppose if I am talking, okay, I'm speaking, so what is happening right now? Right now, the air particles, okay, these the particles in the air, these are getting deflected, okay, uh, because of my vocal cords, okay, they are getting deflected, and that deflection is carried out in which way? In compressing it. Like, suppose if there were the particles like this, so if someone will speak, if someone speaks something, then what will happen? These will be compressed this way, right? And again, these particles are striking against these particles, then again these will strike against these particles, so these will keep colliding, okay, in this manner. So these types of waves which are generated are called actually which waves? The waves which move in direction, okay, these waves are called primary waves, or P waves, right? These P waves, primary waves, can walk through solid also and through liquid also, right? So whenever there is earthquake on earth, okay, then the primary waves can be, this is core, this is outer core, and this is mantle, right? And this is crust, mantle, outer core, and inner core. So if wave travels, then primary wave can go through like this, here also, and here also, and here also, right? Like this, in that manner, here also, right? Or here also, like this, here also, and here also, like this, it can travel. It can go through the, it can go through, right? So these primary waves can originate from here and will travel through crust also, through mantle also, outer core also, and inner core also, right? Will cross again this, okay. So these primary waves are able to cross crust, to cross mantle, and to cross what, outer core and inner core also. So these are the P waves, primary waves. Okay, but the secondary waves are not able to cross what, the outer core, right? They are not able to cross outer core, and they get deflected. Like, this is inner core, this is outer core here, and the primary waves, how secondary waves move? Secondary wave moves perpendicularly to the direction of motion. If their direction of motion is this thing, right? So they move perpendicular in that manner. How it moves? It moves this way. Secondary waves, suppose this is the direction of motion, so the secondary waves will be deflected this way. They move perpendicular to the direction of motion, right? In that manner. So in that manner, what will happen in that manner, if these are moving in solid, so through solid they can pass, but through liquid they cannot pass. Why? Suppose uh, secondary waves are moving this way like a rope, okay, this way they are moving, huh? And in solid, suppose I ask you to stand like this, one student and another student, his arm locked with another student like this, okay, then another students like this. When your arms are locked, okay, and you are standing this way, and I give you a secondary wave shock, okay, like this. So then you all will be moving in this manner, okay, in this manner, in this manner, right? Now here our arms were interlocked. Why? Because we were solid, okay. But in liquid, how are the atoms? In liquid, atoms are free, they are not compressed with each other, okay. So again, if we stand like this, one student, okay, and another student stand like this without interlocking hand, okay, and third student stand here without interlocking our hand, okay, without interlocking, because we are the molecules of water, okay. So then if one secondary wave is getting generated, I do first student like this, then it will remain there only. First student will be moving perpendicular to the direction of motion, okay. There will be no effect on second student and third student. Clear? So why it is happening? Because when the molecules are closely attached to each other, that is in case of solid, then though it can move perpendicular to the direction of motion, right? But when the molecules are free like water, okay, they are having intermolecular, the bigger intermolecular space. When the intermolecular space is higher, okay, then what will happen, that secondary wave will not be able to generate in that medium. Getting or not? So that is why secondary waves cannot pass through the water, okay. So whenever earthquakes takes place, okay, then what happens, the secondary waves move this way, like this, like this, like this, like this, right? Till where? Till here only, till 2900 kilometer, 2900 kilometer, okay. And here, like this, like this, like this, okay, 2900 kilometer. This is the direction of motion, this is the direction of motion, you can say. Clear? But they are not able to cross this one area which behaves like a liquid. So now we can understand that as they are not able to cross area behind this one, so it means that okay, the outer core of the earth is what? It is having characteristics of liquid, so it is liquid, right? So what we are trying to know, we are trying to know okay, how the earth is from inside, okay. So we have come to know one thing, that okay, up to 2900 kilometer earth is solid, okay, and after that it behaves like a liquid, okay. That two things we have come to know from where, from seismic waves, okay. Then second thing, volcano. When volcano erupts, okay, molten rocks comes out, which is called lava, right? This lava is very very hot, the temperature is around 2000 degrees celsius, okay. So we can come to know that okay, the temperature of earth is very high, okay, from inside, eh? That we are coming to know from where, from volcano, okay. Then meteorites are the celestial bodies, okay, which fall on earth from space, right? Whenever meteors traveling near earth is attracted by the gravitational pull of the earth, it enters into the space of the earth, and most of the meteor is burned because of the atmospheric friction, right? And the thing which is left, okay, the leftover part strikes on the surface of the earth, and that is called meteorites, okay. So that meteorite is considered to be constituted of same material as earth is constituted, okay. So we study the material of the earth because both are composed of by same material. So this meteorites also tells us about the composition of the earth, how earth is from inside. Clear? So these three things, seismic waves, volcano and meteorites, gives us information about the interior of the earth. Now what are the characteristics of the interior of the earth? Okay, first we will study about the density, right? We come to know about the density, okay, from where? From the seismic waves, okay. When these p waves, primary waves and secondary waves move, okay, primary waves moves faster in the dense medium, okay. Denser the medium, it will move more fast. Getting or not? So the when these are recorded on seismograph, okay, then we find that came the upper crust of earth is not that much dense. It is 2.3 uh, gram per centimeter cube. That is the density of uh, upper crust, okay. And then afterwards, just a minute, let me check density of earth. Okay, so then after crossing the after crossing certain area, right, after crossing, suppose this is earth, okay, this is earth, and